Now we'll talk about the rotational molding. Rotational molding is generally used to make large, hollow, and one-piece plastic product. It is best known for the manufacture of tanks and toys like a flamingo you see in people's front yard or the kids' toys. It is suitable for small and complex shapes. This is the description of the process. So the first step is to load a certain amount of polymers, usually in a powder form, into the mold. Then we will heat the mold in an oven while it's being rotated until all the polymer has melted and adhered to the mold wall. If you let it cook for too long, remember your material might degrade. If you cook them too short, some of the material may get a chance to completely melt it. Now, then you will cool your mold by air and then liquid. If you cool it too fast, you might have some warpage problem. Once your product has been cooled, you can open your mold and remove your product. This is a description of the picture, just showing the process we described earlier. Loading material, heated and rotated, and then cools, and then open your mold, and you're supposed to get your product. Alright, here is the temperature profile, and you can see the red curves. This is the temperature of your oven, which is very different from the temperature of your plastics in the blue curve. However, the plastic temperature file is very close to the temperature of the inner air. So the industry, in fact, use the inside air temperature profile to figure out what's going on with the plastic inside the mold. For example, here the powder is being heated and the powder is while being rotated. Now some of your plastics start to melt, right? Another transition tell me you can see majority of your plastics has been melted. Then we start the cooling step, and the plastic powder will start the solidification process. When you see this little transition, it tells me now your product has been separated from the wall. Remember, upon cooling, the thermal contraction coefficient of your plastic generally is 10 times higher than the metal. So in other words, your plastic will shrink 10 times than your metal mold. That's why the product can separate at the end. And this is a summary of the internal air temperature inside the mold. And here is the A, B, C, D, E. And this is what is happening at a different position. The A at A point is the powder first stick to the mold. At the B, the powder has been consumed. And C, when the optimal melt centering has occurred, then at the D point, the material has already solidified. At the E, your plastic product already separated from the mold. And this is how people in the industry monitor the performance of your plastic powder inside the mold. Alright, hopefully you learned some about the rotational molding.